The last fundamental way that we're going to see we can stabilize a negative charge is through inductive effects. In other words, through induction. This is when an induction occurs when we have electronegative atom, like one atom or more than one electronegative atom nearby that negative charge. And what induction is and how it's different than something like resonance is that we are actually spreading that charge throughout the sigma bonds in the molecule. So we're really pulling the charge towards that electronegative atom. And it's we don't have a real way of showing that in terms of any arrows other than just the dipoles. And so what's happening, for example, if we take a look at these two, we have a negative charge with an H attached versus a negative charge with a fluorine attached to it. The fluorine is very electronegative, much more electronegative than the H, and it's going to be able to pull electrons towards itself. So we can kind of show what's happening in that bond to the carbon. It's going to be pulling the electrons towards it, and that's actually going to help to stabilize that negative charge because it's going to be spread out through that bond being pulled towards the fluorine. So that's going to help stabilize that negative charge versus the hydrogen that can't really do that because it's not that electronegative. And so what we're going to be looking for with inductive effects is a lot of the times with halogens, these are really good at stabilizing the negative charges. So things like fluorine, chlorine, bromine, we're going to be looking for those types of atoms nearby that negative charge to see if it's stable by inductive effects. So in this case, we're going to compare methanol with trifluoromethanol. And the first thing we're going to do, just like we normally do, draw out that mechanism to get that conjugate base. And the reason that drawing out this mechanism and thinking out, or at least thinking about this mechanism when you're drawing out the conjugate base, is that we want to make sure that we're realizing that those electrons from the bond to the H are being dumped onto the oxygen, and so we're dealing with a negative charge. I've sometimes seen people draw conjugate bases out with a positive charge because they're like, oh, it's charged, but they're not really thinking about what's happening with those electrons in the bond. How exactly is that forming? And that's why we always want to think about that mechanism to make sure that we're drawing the right species so we can talk about it properly. And so our conjugate bases are the ones right here. What we see as our major difference right now, we're dumping those electrons onto the same atom, an oxygen again, in both of these cases, but what's nearby is different. So we don't have a polar pi bond nearby. The oxygens are the same hybridization, but what is different is the fact that we have 3 H's on the first one versus 3 fluorines on the second one. Let's draw out what that second one would actually look like. So with this one, we'd have an oxygen attached to a carbon that's attached to 3 fluorines. And this oxygen is negatively charged. What's going to be going on with those fluorine atoms? They're each going to be pulling from the carbon, making the carbon actually pretty electron deficient because it has 3 very electronegative atoms, the most electronegative atom on the periodic table, in fact, pulling the electrons towards them. What that's going to do with that charge is that carbon then is going to pull on that negative charge. And so effectively, that negative charge is spread out through the sigma bonds all the way to the fluorines. And so it's also delocalized in that type of way, not in the same way as resonance, but through the action of pulling by these electronegative atoms, we're able to stabilize that charge. And so that's going to be our more stable conjugate base. It's stabilized through induction. By those electronegative fluorine atoms in this case. Therefore, our CF3OH, its corresponding acid, is the stronger acid. So we're looking for those effects when we're dumping that charge onto the same atom. We don't see a pi bond nearby that we could do any resonance with, or there shouldn't really ever be a positive charge nearby, but we don't see any way to do resonance with it. We don't have a difference in hybridization between the two atoms. but we do see electronegative atoms nearby. And so that's when we know to go to induction. The closer these atoms are, the better the stabilizing effect is. So we're looking at the proximity of maybe they both have electronegative atoms. We're looking at how close are those electronegative atoms to that negative charge. If they have different, if the conjugate bases we're comparing have different halogens attached, like a fluorine and a chlorine, for example, we're then going towards which one's more electronegative. More electronegative will pull more strongly. And so those are a few of the variations we can see with these inductive effects or with induction.